Hello, I'm Seth Jones, and I'm going to tell you about my experiment, a Sublime Experiment. Dry ice is a frozen and solid state of carbon dioxide. Dry ice sublimes at room temperature because it was forced into a solid state from a gas, and is usually at a gas at room temperature and average pressure, so it tries to return to a gaseous form. When solid particles become heated, they move faster, causing them to change states faster. My question is, what liquids and at what temperatures make dry ice sublime faster? My hypothesis is that I think that warmer liquids with less viscosity will sublime the dry ice faster. My materials for this experiment were 1 pound of dry ice, a food scale, knife to break the dry ice, a cooler, containers for the liquids, a measuring cup, half a cup of tap water, half a cup of molasses, half a cup of Sprite, half a cup of nail polish remover, which is 100% acetone, safety goggles, gloves, tongs, a thermometer, and a stopwatch. Right here you can see, here are the tongs that we used, and this is the food scale measuring a chunk of dry ice that is 0.5 grams. My methods. I broke up some dry ice to equal weights, and I used a scale to measure the weight. I heated up some liquids in a microwave and left some at room temperature so that they all had one of each, hot and cold. I took the temperature of the liquids to make sure that the hots and the colds were about the same temperature, not meaning that the hots are the same temperature as the colds. I put the liquids in the containers that they were assigned to. One by one, I took each of the squares or chunks of the dry ice that were the same weight, and put one in each of the containers, and used the stopwatch to measure how fast the dry ice sublimes. Here are my results. So in this table I created, we can see that hot 1 and hot 2, the hots overall were faster than the colds, except for molasses. And you might be wondering, why does molasses just say 20 plus? For the sake of time, if anything got higher than 20 minutes, I just wrote 20 plus, because we would know that it took very long, and that would be enough for my experiment. And right here we can see that the nail polish remover was very fast compared to the rest of everything else. You can see that better in this bar graph I created. You can see that the nail polish remover is very small, black dot thingy down there, while everything else is up there. The molasses is very up there because it took a very long time. And we can see that something strange. Water took a little bit shorter than Sprite every time except for the first time we did hot. Wonder why? Alright, here are my pictures and I will explain what they're used for. This picture right here is showing you what it looked like when we put a chunk of dry ice in the water. You can see that a lot of steam came out, or carbon dioxide, not steam, but it's... down here, you can see the subliming levels of the Sprite versus the molasses, where the thing is still sinking in. It's very viscous. Right here, this is my reaction to the first time we put the dry ice in the acetone because it was so fast. Up here, I am dropping some dry ice into the water, and here I am watching it sublime. Okay, just a refresher, my hypothesis was that I think that warmer liquids with less viscosity will sublime the dry ice faster. In the end, the acetone was the fastest, probably because of something in the chemical makeup. And the molasses was the slowest, probably because of the viscosity. In everyday life, if you were wanting to make fog from the dry ice, you could use hot water for a thicker fog that doesn't last very long. As you can see right here, this was hot water, and it was a very thick fog. Or, if you want a longer lasting fog, you could use cold water or another liquid that is cold that's like not crazily fast or extremely slow, for a thinner fog that lasts longer, as you can see right here or here. Thank you for watching my experiment, a sublime experiment. I hope you enjoyed the information that I gathered, because it was very fun doing it to me. Bye! Cool. Mama, make sure you're ready to pause it right when it's gone. It's going away. Be ready to stop that. It's going really fast. No, yet. And here, this is our Sprite, and this is molasses. And you can see most definitely that the Sprite is subliming at a decent rate, but the molasses one is still sinking in. We already put it in like a minute ago. So I feel like this is going to take a very long time to sublime in the molasses.